Hi guys, pretty much surprised to see so many people to kind of like be interested in governance and zero trust and Iceberg. But I guess like Iceberg is the main thing what people are like to know about. Maybe just for me to understand, is anyone using Iceberg in private? Yes, no, maybe Delta, Hoodie, something like that. Yeah, cool. Well, then let me just dive in. Iveta already introduced me. My name is Viktor. I'm co-founder of a company named Vakamo, so a classical startup, and we created a Lakekeeper. It's Apache Iceberg REST catalog. So everyone who wanna use Lakehouse, you need a catalog. We will just dive in that in a moment, and you can actually take that. Take a try and give a try for Lakekeeper, and afterwards, if you have like any questions regarding Lakehouses, Iceberg, governance, feel free to reach out to me. I'm glad to chat with you about all that topics. Yeah, so Vakamo, maybe just a very quick introduction, is one end startup, on the other end, because I and my co-founder both operate in Europe. We do have a community for Iceberg, so everyone who is in Europe and interested in Iceberg, feel free to reach out to our community, and we do run sometimes meetups, and we're glad to invite you to speak on a stage about Iceberg. And the second topic about Vakamo is that we love open source. We contribute actively to Iceberg, Data Fusion, to Trino, Iceberg, and that's kind of like what we see on a community level. Maybe just interesting to ask you guys, who is using like open source in a daily life? Oh, many hands. Who does contribute to open source? Yeah, not that many. So maybe just a kind of a motivational speak. So contribution is not just writing code. Contribution is just to go to the project, to see the project, maybe to test it out, to find a bug, to issue some kind of topic, to have a conversation, to even to give a start to a project is a contribution. So maybe next year, I will asking the same question, and we will going to see like same amount of hands about the open source contributors here in a room. All right, before jumping to the Iceberg and all that Lakehouse thing, let's understand how we got to this point, and that's kind of a time travel thing and the data evolution. So 1990s, I don't know like if you recall, but that the time of a data warehouse, a monolithical approach where we had our Teradata, Oracle, maybe Postgres. We put all the data inside of that single box, and we could run our reporting system. Around 2000, internet happened, and we've got kind of challenge. We have a semi-structured, unstructured data, clickstreams, IoT data. So how to store that data, how to process the data, and the solution was, well, let's just put the same monoliths close to each other, call it massive parallel processing, and one is like Hadoop, the other one could be like a Greenplum, and that's something what helped us to process like maybe terabytes or petabytes of data, but we had some limitations with collocation of data to compute, and it wasn't really easy to scale and to manage the system. Therefore, the kind of like the whole industry was developing further. In 2010, we got cloud, and probably the main players are here like Redshift and Snowflake, who made kind of a revolution for us. It was a single button of click inside of like whatever portal of Snowflake or Redshift, and you could get the whole cluster managed by someone, not by you, but by the like Snowflake team or Redshift team. But the cool part is they started to decompose the monolith. They got two different layers, the compute and storage, independent from each other, which means you can now go and storage as much as you want. So you can store like petabytes of your data, and then you can provision as much as you need. So if you run a simple select star from table, you don't need a huge cluster. You can just provision a small cluster and run your analytics on top of that. Well, the big data community was not sleeping at the same time, and we've got like Databricks, and Databricks was saying like, why not to make data as an independent tier? And we've got mainly Parquet as a file format, which helped you to store really like exabytes of data and run the parallel processing on top of that. And I think the speaker before me was presenting the Spark thing, what helped you to make all of that kind of crazy analytics and data science stuff. Well, now we have two worlds. The cloud data warehouse with transaction guarantees, with schema evolution, time travel. And on other hand, we have big data systems with immutable Parquet files that cannot have a simple update. You know, like we live here in Europe, we have GDPR, and you need sometimes to go and delete the data of a customer, and it was a huge, huge headache. But it is something what scales pretty well. It's why actually Databricks was so famous at that time. And the companies and like everyone who was using like tried to balance between data warehouse and big data system, data lake. And luckily for us, we've got a new paradigm named a Lakehouse that actually unified a data warehouse with transaction guarantees and schema evolution, and unified what data lake enabled us to scale pretty much. And to achieve that, we got the open table formats, and Iceberg is probably the main format nowadays, but in early days we've got something like Delta, developed by Databricks, and Hoodie, developed by Uber. And Iceberg was developed by Netflix, Ryan Blue and Dan Wicks, and they open source the whole stuff. And it's quite cool what you can achieve with that. But maybe the interesting part of Lakehouse and Iceberg is that the separation of metadata and data. So data is still Parquet file, but then there's a kind of a magic part is inside of meta that will help us to build the governance with that. And on Lakehouse, you don't need a database. There is no database at all. The whole data stored as a Parquet file, so you can store literally, like according to Netflix, over 1 exabyte as Iceberg open table format that uses Parquet. So no relational database needed for running a huge analytics workload. Well, just to simplify, what's a Lakehouse? It's storage, it's a compute to read and write, and it's a catalog, because you need a catalog that is primarily, if you run your create table statement or insert statement, what catalog will do, your client, your Spark, your Python, will go to catalog and ask, oh, I want to read that table, the table customer, so I need to go and ask where is the location of that table. So it will tell me, oh, you should go to S3 path, and then you can read the table. And then, in addition to that, the catalog will issue a token to a client, so you don't need anymore ask anyone, or can you give me access key and secret key from that S3 storage. That is all done through a mechanism called vended credentials. So the storage will vend the credential that will live maybe for 1 hour, which is one of a thing what you need for zero trust. So what is actually Iceberg? Any guesses here? What's Iceberg? We had some kind of users. Yeah, go ahead. Correct. It's open table format. So just to summarize, Iceberg is a bunch of specification. So Iceberg has a specification for a table, how a table looks like, a view, a puffin, which is like for statistics, and a REST catalog specification. So it's a bunch of specification and kind of a good luck wishes from a community on implementing that specification. And that's why sometimes you can hear like, well, it's not quite easy to implement the whole stuff. So you need to cope with a lot of challenges. So what my company, my startup, has actually started to do is to implement the REST catalog specification. It's where we created Lakekeeper to provide you an easy way to build a lakehouse. A quick evolution of Iceberg catalogs, because it's quite interesting how the community started. So that's a famous Iceberg picture. So if you're on a meetup or on a talk about Iceberg, you should actually kind of get presented that picture, which will show you exactly what's going on here with Iceberg architecture. So you have, maybe starting from the bottom, the Parquet files, the data files. Then you have a metadata layer. That is exactly the thing that allows you to treat the file as a table. Because if you will just go and then read the table, you will just run select star on something without having any database. And at the top, you have a catalog which is actually responsible to tell you where a table locates. And at early days, we had all the different catalogs, Hive Metastore, Hadoop catalog, JDBC, Nessie. And it was very confusing for the clients like Spark, Python, Trino to implement the whole proprietary way of a catalog to communicate and be able to read and write Iceberg. And therefore, it was made a decision to unify and to create a new spec, the REST spec, for the catalog. So now everyone can actually implement the catalog, and every client who want to read Iceberg now just knows, okay, we have that bunch of APIs, what we need to use, and then we can go and read the table. And the funny part is that they made a decision that catalog will write the metadata JSON file, which is actually needed to make a final commit. So like on a database, if you write to a database, it will someone is like in charge to make a final commit, and that's what catalog is now doing here. So in 2022, we've got the catalog specification, and we started to build the whole thing. It was quite confusing at the beginning, because if you started to explain what Iceberg is and that you need a catalog, you got like an answer, or we do have a data hub catalog, or we have this catalog and that catalog, and that was a confusion between a business type of catalogs and Iceberg technical catalog. And luckily for us, in 2024, we got more competence on a catalog side, and we started to call it a meta store, which was quite natural, because in the early days we had a Hive meta store for the Hadoop. Hadoop is now more or less retired, and now we are on Lakehouse, where we have a meta store. And finally, when we talk today about this specific thing, is that we talk about the control plane, because it's not just about to tell you where the Iceberg stores the Parquet files, but now you have an easy way to manage access, to manage governance, and to establish trust, because the whole thing goes now more towards AI and agentic workload. And if you don't have a human anymore in that story, it's hard to make a trust, and that's the idea of the catalogs. Quick introduction of Lakekeeper. It's a control plane, and as you can see, if you build a Lakehouse, you have all the different storages where you will store the Parquet file. And then you have all the different compute engines. So if you on a streaming use Kafka, there is a Kafka Connect, you have Apache Iceberg, you have Spark, DuckDB, you can go and use Snowflake and Trino and just read through a single control plane, which does not require a database anymore to store the data, but requires just this type of architecture. And control plane is in charge of table management and maintenance, so which means if you create an Iceberg table, you need to take some actions. For fine-grained access control, where you want to say like, okay, Alice has access and Bob does not have an access to data, and then establish a trust for data and AI governance, where we have a little bit different type of requirements, especially on AI, where AI acts in a probabilistic way, and governance is actually deterministic, where in a governance you have to be 100% sure who is entitled to read the table or not. So question maybe to you guys, what Apache Iceberg actually did solve? Any guesses here in a room? I love ask questions, just by the way. So 100%. That's exactly what Iceberg solved. So now we have a single file, imagine like that. So you will store your data about your customer as Iceberg in that format, and you can use whatever you want on compute engine. And so if it's small query, you can use DuckDB on your laptop. If it's a large query and you need kind of a multi-user system, you can go and take a Trino, Snowflake, or Databricks. You're not limited anymore to a compute engine. So which means at the end of the day, you don't need to migrate your data anymore. You know, like the situation when you started with Teradata and then someone proposed, oh, let's use Snowflake, and the next manager said, Databricks is a cool tool as well, let's move to Databricks and maybe something else. And the companies usually spend years and years on migration. So that time is over. So if you want to build an analytics system, you will probably use Iceberg, store the data as Iceberg, and then use whatever you need for your use case. The compute, whatever you want to use. Go ahead. Sure. So probably just give a sec.
So I follow this space with great interest, but in my case, I just use SQL Server or like just a database, and that's more than enough. So where do you see, I mean, this is more interesting when you, I guess, cannot scale a single monolithic database, or otherwise I always have a hard time to figure out what's the point if you're not Netflix and you're not Facebook, and you basically just have one SQL server and that can do basically everything that you need.
Yeah, so the volume is one reason where you will think about that, but interoperability is not about the volume. Interoperability is if you have, I don't know, like the size of your company, but then you store everything in a SQL server, and then someone is asking, oh, I want to run this function, which is in a Postgres or in DuckDB. And you will say, oh, well, let's reach out to Microsoft and ask them to implement that function. You probably will wait a couple of, I don't know. So the thing is that your use case and size of your company, size of and amount of your use cases is actually the thing that determines should you use Iceberg or not. If you're a small company with 5 persona, let's say, and you have 3 use cases and everything fits inside of SQL Server, just keep it. Don't make, because you saw the complexity where you have all that moving part, and we will just go to the complexity in a minute. So the question is, if your SQL Server is capable to cope with the volume of data and with amount of your use cases, you're good to go. Maybe Postgres is better than SQL Server, I don't know. Don't want to argue that, but that's kind of like the case. So volume is not the only criteria to make a decision for Iceberg or not. All right, so that's interoperability. A great comment, great answer. So the next question is, what did Iceberg not solve? Any guesses? No. So how do you know? Have you seen my slides? That's exactly the case. So right now we have the description about how to store the data, how to write the data, how to read the data, but we don't have like a standard about the fine-grained access control, how to manage that, how about the column masking, row filtering, lot of different things. And what is actually happening right now, you see that every vendor out there, so I took just Databricks and Snowflake, but if you will go to Microsoft, to Amazon, to Google, so they built that governance inside of a catalog, and which means you need to either comply with that vendor-specific way of a governance, which is kind of a proprietary way how to manage that. And here's similar thing that if you're a company that has only this technology, you're probably good to go. If you go to a larger companies, you will find that they have all of them. You will find a company that uses Databricks and Snowflake, just 2 departments. And as a result of that decision about like where governance will be implemented, they start fight each other more or less, right? So the department A with Databricks want to use Unity, department B with Snowflake want to use Horizon, and there's a AWS with Glue Catalog, and so on and so forth. And that kind of like limits then the company to concentrate and focus on things to implement. And what we from our company standpoint see, like why not to change the whole thing and say, well, we will just put the governance inside of a catalog which is independent from a compute engine. And that's something what Lakekeeper was built for. So and the idea of how we implemented that is not to use a proprietary way of governance, but use the open standards that we have nowadays in our open source community. Just to present you that, so how we manage the open governance here. So Lakekeeper, by the way, it's written in Rust, single binary, so you can use a Helm chart and deploy the whole stuff on Kubernetes, and I will show you like how to do that locally on Docker Compose. But the thing is that Lakekeeper will run somewhere, and what you need is an object storage to start with. The decision what we made that Lakekeeper is not the IDP, and that is very important. If you will use a system that will pretend to be an IDP, and then you have somewhere your keycloak, entry ID, Okta, then you have two different IDPs that is kind of like the conflicting situation, because imagine the day where your employee will leave the company and you will disable that employee in your central IDP, and then you have your IDP in your data platform with personal access token. So and depending like how that employee left the company, who might have still the access to your data. So it's not a nice situation, right? So therefore, our decision was made that we are not the IDP. We will connect to your central IDP, which is like the best and secure way, and from a zero trust perspective, the only way. The second thing what we made is a decision that the authorization is not part of the catalog. The authorization should live outside, but very close to the catalog. And for the open source solution, we took the authorization system based on OpenFGA, which is the implementation of Google Zanzibar paper. I don't know, anyone heard about Google Zanzibar? Yeah, cool. So that's a relational based access control. It's a superset of airbag and abag that allows you actually to implement in a way the whole authorization. But to simplify that, what is OpenFGA? You have the authorization tuple where you have object, action, and principal. So like customer table, Bob can write. That is what we're gonna store inside of that OpenFGA system. But the cool part of that is it's not tied to the catalog, which means you can replace the catalog all the time. And you can even build your own authorization system. So because inside of Lakekeeper, it's a trait in Rust, and you can go and implement your authorization system as well. In Iceberg, we differ between two compute types. So the first one is a general compute, and it can be like a Python job, a Spark job, and usually that is a service principal that will connect to your Lakehouse, to Iceberg, and read it. The issue is here the nature of Iceberg, because the general compute will go and read and write the whole Parquet file that might have too much data, and it will actually be over provisioning from a governance perspective. And therefore, you got to be careful on a general compute how you're going to treat that. And to solve the problem of over provisioning, we have a trusted compute. And usually the trusted compute is a multi-user systems like Trino, Starox, whatever type of a system that, first of all, in charge of managing hundreds of users inside of your company, and then you need to tell like, okay, that user or that group can read or cannot read. Because at the end of the day, the trusted compute itself connects to Lakekeeper with a super admin, and then you need somehow to downscope the permission for that specific user. To achieve this, we have one additional open source technology, Open Policy Agent, that is a bridge, allows Trino to communicate with OpenFGA, where Trino will exchange the information that, okay, we have a user Bob or Peter, and Peter can read the information, and then we have a user Anna, and Anna has no right to do so. And let me introduce the enterprise-ready, open-source, license-free Lakehouse system based on Apache Iceberg, cutting edge. So that's something what you can actually use nowadays. So you don't need any big vendor in a way then you want to build a Lakehouse. But back to your comment, it is some complexity. So where you have a single box from 1990, SQL Server Oracle, that manages everything for you, to something like that. But the benefit is that you can scale every component here. And if it's small data, small amount of use cases, keep it simple. If you have large amount of data, you got to think about that. And on scalability, you need to scale then your governance. All right, so Linus, talk is cheap, show me the code, and I do have a quick demo here to present exactly this thing. Let me just go here. Yeah, just what I'm going to show you, you can go to our repo, and there is a folder examples, and there are different examples, and I will go to that access control advanced, and it has everything, and to run it, you need just only Docker Compose up, and then you have everything on your laptop to run it. In the first place, what you will get is here a Jupyter notebook that requires some steps to bootstrap the Lakekeeper. Then we need a step to create our first warehouse. Yes, and then what we are doing in that case, we're connecting to Trino to create a catalog. And if we have everything in place, now we have a user Peter, and let's just run a select statement on finance.products and see if Peter has access, and voila, we've got data. Now let's assume we have Anna, and now I'm in a private here browser session to have like a different user experience, and now Anna is going to run the same query on the same data and needs the authorization. Yep. Looks good, but not here, which says permission denied. And that's exactly the expectation. It's, you know, like sounds quite boring, but if you distribute it, kind of not really controlled type of a landscape, it's very hard to achieve. But due to all that technologies what we have here in place, it was possible to achieve. What Anna can do now, she will go, let's say, to Lakekeeper, log in, and see that she has no access, and will ask just Peter, or can you please give me the access? And Peter will go to Lakekeeper as well, sign in as Peter, and Peter will go to the warehouse demo, finance, tables, products, and we'll say, okay, let's give Anna access, select, save. So now Anna should be able to read the data. So if she will check status, she now see the demo, finance, and see only one table products, where Peter was able to see more data and more tables. And if Anna will repeat the same query now here, with authentication here, now Anna is able to see the data. And that's the way how you can manage a Lakehouse Iceberg. Even though if it's all distributed, you have a simple mechanism to achieve a governed solution. And maybe just one more thing about the interoperability. I have here as a Peter, so I was using Trino to read the data, and now I can use PyIceberg, read the same data, which is not working. Let me, okay. Yes, here we go. So now Peter sees the same data. So that's the use case of interoperability using different technologies, reading same data, which is not tied to any vendor, any technology. All right. So, but the question is right now, how can we reduce the whole part of complexity? And the idea was, okay, so now we have Open Policy Agent, and we have additional OpenFGA that needs to be operated by someone. But in case we can actually reduce that, where we have an additional type of technology, a Cedar policy. Anyone heard about Cedar policies? It's an open source policy engine and technology, and it was open sourced by AWS. That's quite interesting that Amazon is in open source space as well and innovating. So what Cedar policy is actually able to do is to create the way that will allow someone to read, and you will predefine the policy upfront, even if you don't have that data. So which means you will define the policy and allow someone to read and to write. And that is a permissionless code, because how we will implement that, first of all, we will use the zero trust. So we need to verify every request. We need to apply that zero trust on policy with last privileges. We will issue a short-lived credential, not just in case a user with password that will live forever. We will create something for 10 minutes or 1 hour. And so we need to think about how to limit the breach. So if somehow the user is now accessible, or data is accessible not for the whole lakehouse, maybe only for a single table. So the governance flow. And the best thing is to describe that with a separation of power. And you probably know what separation of power is, because that is a system where we live, right? So in a system where we live, we don't have like one authority that makes everything. What we made as a decision as a society that we need to separate the powers, and same on the governance side. So what we have is a legislative thing. So someone in our organization is defining the policies, and it goes usually to a Git, and it's versioned, and it's approved, and so on and so forth. And it's deployed to an executive, and which is like a Lakekeeper catalog that will make a decision, allow or deny. And finally, if the whole thing is actually done, we have audit log pushed to a judicial, where someone is taking care and understanding, like, was it good or not good? And then that feedback will go back to legislative to make that decision. So this is like the way how we think the governance should work. So we do not want to have a dictatorship, like a simple box somewhere, like a Microsoft SQL Server that will do everything for you. We want to just distribute that and separate the power, especially in a time of agentic. You don't want to have like an agent is capable of doing everything. You want to have this type of separation of power. And the whole idea of Lakekeeper is, let's just do peace and not kind of like fight inside of an organization. For someone who doesn't like separation of power, I have a different solution. It's a Switzerland solution, a neutral field. You can just put it there, and if you want, you can build your dictatorship in Databricks and Snowflake, but not for the governance. Takeaways, Iceberg, one interoperability, but needs to be better on the governance. The catalog is actually the place where you can enforce the whole thing. That needs to be centralized in a way, but with a separation of power. And I think Lakekeeper has quite interesting way to achieve that. And I need to get to the end, but that was my talk about the way how you can do the governance, how you can do that permissionless code. And if you have like any questions, I think we have a couple of minutes. And if you want to give a try Lakekeeper, give us a star. Thank you very much.